Hello everyone, how is it going? I hope you all are doing well. So I again welcome you all in this session. This is going to be lecture number 6 of this chapter, Sources of Energy. So let's move on to the next slide. Okay students, so here we are. So from this slide, what we will be doing, we will be solving some of the questions on this chapter, Sources of Energy. Okay, so we will start solving these questions one by one, and as you can see on your screen, this is your question number first. So first of all, let's read this question, what it is saying. So a solar water heater cannot be used to get hot water on a sunny day, a cloudy day, a hot day, or a windy day. So basically here in this question it is asked that a solar water heater will not be able to work on some day which has been given on the options. So it may be a sunny day, a cloudy day, a hot day, or a windy day. So we have to answer that on what day a solar water heater cannot be used. So to answer this question, first of all, let me tell you some very important points so that we can also revise our concept. So students, we all know that in solar water heater, what will happen? The solar radiation which is coming from the sun incident on the solar water heater, and then it will boil our water. So basically, first of all, let me tell you that the solar radiation which comes from the sun, and sun is the unlimited source of the solar radiation. Okay, because sun is what? It is a hot sphere. Okay, now these radiations come from the sun, and this basically incident on the solar panel. This is our solar panel. Okay, now guys, we all know that in solar panel we use silicon. Now what is this silicon? This silicon is basically a semiconductor. Now guys, what happens that it is the property of semiconductor that they behave as a insulator at normal temperature. But when we increase the temperature, so it starts behaving like conductor, or it starts conducting electricity. Okay, so guys, what will happen when the solar radiation incidents on these silicon? So the electron comes out from the atoms and the electricity starts to flow. Okay, electricity starts to flow, and let's suppose the current is flowing in this direction like this. Sorry, the electron is flowing in this direction like this. So we all know the direction of current will be opposite of the direction of the flowing electron. The direction of the electric current is taken as the opposite direction of flowing of electron. Okay, I hope guys this point is clear to you. So basically we all know that silicon acts as a insulator at some temperature, but when the temperature increases, so it starts conducting electricity. I hope guys this point is clear to you. So guys, in short, we can also say that the light energy is converted into the electrical energy. Okay, and I have also given you the explanation how does it get done. Basically, when the light rays falls on these solar panels, so these solar panels produces or generates electricity. I hope this point is clear to you. So now come to our question. A solar water heater cannot be used to get hot water. So the first option is sunny day. So this cannot be the answer because we all know that on sunny day the solar radiations are available in enough amount. So this cannot be the answer. Okay, now a cloudy day. So this will be our answer because we all know that on a cloudy day the sun rays are not enough, okay, to generate electricity. So that's why a solar water heater cannot be used to get hot water on a cloudy day. I hope guys this point is clear to you. So this is all about the solar cell. In this question I have told you that these are the solar panels and these solar panels are made up of the silicon, or you can say these are made up of solar cell, and solar cells we use the metal silicon to make solar cells. Okay, and silicon is what? Silicon is a semiconductor. So at normal temperature semiconductors are insulator, but when you increase the temperature, so semiconductor starts conducting electricity. I hope guys this point is clear to you. So now you might have seen the applications of the solar cells. Okay, on the most of the houses of our roof we install these solar panels. Okay, so next time whenever you see a solar panel you will remember this class. Okay guys, so let's move on to the next slide and let us talk about the second question. So the second question is, which of the following is not an example of a biomass energy source? So which of the following is not an example of a biomass energy source? So as you can see, this nuclear energy, if I talk about these four options, so it is clearly seen that, so in nuclear energy we all know that we use two type of reaction. First one is nuclear fission reaction and the another one is nuclear fusion, and we all know what is the difference between them. In nuclear fission reaction the nucleus is divided into a smaller nucleus, but if I talk about the nuclear fusion reaction. So here a small nucleus combine to form a big nucleus. So that is the difference between nuclear fission and nuclear fusion. And this nuclear fusion is basically the source of the energy on the sun. Or you can say this type of reaction takes place on sun. I hope guys this point is clear to you. So this nuclear fission is used in the nuclear reactors. Nuclear reactor, because in nuclear reactor we use high amount of heat. So these reaction produces high amount of heat which can be used to boil water, or you can say it can be used to convert water into the gaseous state or into steam, and this steam is used to rotate the turbine, and whenever turbine rotates it generates electricity. So this is your answer. I hope guys this point is clear to you. So now let's move on to the next question. Okay guys, so next question is question number 3rd. Most of the sources of energy we use represent stored solar energy. Which of the following is not ultimately derived from the sun's energy? So basically in this question it is asked that which one is the answer which is not derived from the sun's energy. So let's answer this question. So guys, what is geothermal energy? We had discussed it very deeply that the energy present in the crust of the earth is basically used to generate electricity. Okay, so that energy is geothermal energy. Now we also saw what is wind energy. Okay, and we had also seen nuclear and biomass energy. So if I talk about biomass, so biomass is basically what we eat. Let's suppose what is the source of energy of humans? What is the source of energy of humans? So we all know that the source of energy of humans is the dead plants. Dead plants. Okay. Now these dead plants, or you can say the plants also have energy. So where does this energy come from? In plants. So this energy comes from the sun. The energy in plants also come from the sun. Okay, so you can say that biomass is dependent on the sun energy. Okay, so you might have heard the photosynthesis. So by this process the plants basically produce or synthesize their food. So this energy, or you can say the source of this energy, is also sun. So biomass is basically it is dependent on the solar energy. Okay, now let us talk about the wind energy. So why the wind flows? We all know that wind always flows from high pressure to low pressure region. Let's suppose here on this region there is high pressure area. There is high pressure area, and let's suppose this is low pressure area. So wind will blow from high pressure to low pressure, and this is used as wind energy to generate electricity. Okay, now guys, why this low pressure area is created? So here also the sun is responsible. So basically the heat coming from the sun, what will it do? It will increase the temperature of this region. And whenever the temperature increases, so the wind present here will move upward. Okay, so that's why here at this region low pressure area is formed. So that's why the wind starts flowing from high pressure to low pressure area. I hope guys this point is clear to you. So I hope that you might have been able to understand that how wind energy is also dependent on sun. Now let us talk about option number C. So option number C will be the right answer of this question, because in nuclear energy we had seen that there are two type of reaction: nuclear fission and nuclear fusion. So let us talk about nuclear fission. So in nuclear fission, what happens? One nucleus divides into two other nucleus. Here, what happened? The mass of this nucleus is not same the mass of the sum of these two nucleus. So you can say the initial and the final mass is not same. So this is known as mass defect. Okay, so due to this difference in mass, you can say, let's suppose there is some mass m of this nucleus, but after this nuclear fission the mass of this nucleus is, let's suppose, m1, and the mass of this nucleus is, let's suppose, m2. So here this capital M is not equals to m1 plus m2. So you can see there is some difference in mass. So this mass is converted into the energy. This mass is converted into the energy. And I had told you the relation between the energy and the mass, that E is equals to mc square. E is equals to mc square. Okay, so you can see that this mass is converted into the energy. So this is very high amount of energy, because we all know that value for C is equals to 3 multiply with 10 to the power 8 meter per second. So this energy is very much. You can see that E is equals to mc square. When you put this value here, so this equation will basically, you can see that it is c square. So that's why this energy is very much. So I hope guys this is clear to you that the answer of this question is nuclear energy. Now let us move on to the next question, and that is, on what basis would you classify energy sources as renewable and non-renewable, exhaustible and inexhaustible? So basically here we will be discussing that what is renewable and non-renewable energy sources. So, renewable sources, the source of energy that replenishes in nature, is known as renewable source of energy. For an example, sun, wind, moving water, biomass. So basically these are unlimited sources. Okay, it is not, you can say you can renew it. So that's why these are renewable sources. Now let us talk about non-renewable sources. So the source of energy that does not replenishes in nature is known as non-renewable source of energy. So non-renewable source of energy are just opposite of renewable sources. Okay, they are not going to renew. You cannot renew them. So example of these non-renewable sources are coal, petroleum, natural gases. Okay, so these are the examples of non-renewable source of energy. Now guys, let's move on to the next slide and let us talk about the exhaustible and inexhaustible sources. So as you can understand it by the name, that if I talk about exhaustible sources, so these are the sources of energy which will deplete and exhaust after a few hundred years. So basically we all know that the coal and the petroleum are not unlimited sources of energy. They are going to finish at some extent. So that's why these sources are not unlimited. So that's why these are exhaustible sources. Now, what are inexhaustible resources? So these are the sources which will not exhaust in future. These are unlimited, like biomass, okay, like solar energy. So these are what? These are inexhaustible resources. So I hope guys this point is clear to you. This example is clear to you. Now let's move on to the next slide and let us talk about the examples. What are the qualities of an ideal source of energy? Okay, so this is also a very good question. In this question, it is asked that what are the ideal sources of energy. So a good source of energy should have these qualities. First one is that it produces a lot of heat per unit mass. So if you heat 1 unit mass of that source, so it should produce lots of heat as compared to the other source. Now it does a huge amount of work per unit mass. So for per unit mass, it does a huge amount of work. That should be also a characteristics of this, you can say, resource. It is easily accessible. Okay, it should be easily accessible, like LPG, liquid petroleum gas, which we use in our houses. So that is easily accessible, and it is very easy to store and transport LPG. So that's why it is also a good source of energy, and it is economical as well. So that is also a property of an ideal source of energy. And the smoke produces should also be very less. So we can also see that when we burn coal or charcoal or wood, so we had seen that it produces lots of smoke. But when we burn our LPG, so it burns with a blue flame. That shows that there is no smoke. So it burns completely. So it does not produce so much smoke. So that's why it is also an ideal source. So I hope guys whatever we have seen in this lecture is clear to you. Now we will end this lecture. So thank you so much students, and Bye bye.